Question number 2. It says a ring of radius A. There is a ring with radius A contains a charge Q distributed uniformly over its length. Okay, fine. Find the electric field at a point on the axis of the ring at a distance of x from the center. So let me make here a perfect circle. So let's imagine this circle here. Okay. So this is our ring, and this ring, okay, due to this ring we have to find electric field. Where we have to find electric field? Okay, along the axis. Okay. So this is our any point at a distance of x from the center. Okay. And from this point, let me make a straight line here, our radii. Okay, so this is our radii. Wait a minute, let me make it straight. Okay, here it is. Okay, so this is our any distance A. Okay, so this is our ring, and the blue region is whole filled with charges. Okay, let's take O as a center. Let's say this is the point A where it is meeting. And let's imagine a very small part of charge here, dq. dq is what? A small part of charge. Infinite small charge here. We will integrate this charge to get the total charge which is all over the ring. Correct? And due to the small piece of charge, at any point P, the field will be what? The field will be radially outward, right? So let's join this point. Joining this charge, small charge, and point P, and at this point the field will be radially outward. But this field, since the charge is dq, that field will be also dE. Okay, it won't be total electric field, right? We will integrate this dq to get the total field at point P. Okay, now let's draw this straight line here. Let's finish it. So this, if we assume angle theta, what will be the component of dE along this side? It will be dE cos theta. If this is our electric field dE, then component of dE along this side will be dE cos theta. Sir, why you are considering dE cos theta and not dE sin theta? Be very careful. Very important concept it is. dE cos theta lies in this direction, then dE sin theta will lie in this direction as usual. Correct? But as we have seen in the previous problems also, if dE sin theta goes down, and if we imagine a small piece of charge over here, and we try to figure out our field in this direction, then because of that, the component of electric field along sin theta will be upward. These two components will cancel out each other. That's why we don't consider sin theta. Okay, we only consider cos theta, because all the cos thetas will add up, while all the sin theta will cancel out because of opposite in directions. Cos theta will be along the axis, while sin theta will be normal or perpendicular to it. I hope this is clear. So what will be the field due to this infinite small charge? So that will be dE, that is equals to dq kq. K is what? 4 pi epsilon naught q, and what's the charge distance? AP square, right? From that point A to point P square, AP square. Great. Now this is dE, but our net electric field is what? That is along x-axis. So dE cos theta. So dE cos theta, okay, that will be equal to how much? dE cos theta will be equals to dq upon 4 pi epsilon naught AP square and cos of angle theta. Correct it is. Now what's cos theta here? If this is theta, this will be also theta. Correct? Vertically opposite angles. And if that is theta, then what is cos theta? Cos theta is base upon hypotenuse. So let's put here, what is our base? OP upon hypotenuse, AP. Great. Now let's figure out what is our AP over here. So if you use the triangle AOP, AP square will be equals to OA square plus OP square. So OA is A, OP is X, that is our AP square. Great. And what will be our AP? Root under A square plus X square. Let's substitute here these values. Okay. So this will give us the total electric field. Okay. That will be E, which is equals to integration of dE cos theta. We have to find it due to all the charges, not only due to dq. So dE cos theta, and this dE cos theta will be equals to integration of dq upon 4 pi epsilon naught AP square and AP, that will be AP cube. So let's find it here, root under a square plus x square, that is AP whole cube into OP. Correct? And what's OP? Look at the diagram. OP is x, so into x. I hope this is clear. Now let's take the common out constants. Let's take the constant out of the integral. What are the constants? What are the values which will not change? Okay, that is x upon 4 pi epsilon naught. And this root and that thing I am writing it as a square plus x square whole power half. Root is half and whole cube. To make it simple, that is also taken out, and integration of dq. Correct? Now integration of dq will give us nothing but the charge, the total charge, because integral gives you the total sum. So this will be q whole divided by 4 pi epsilon naught, and this half and 3, that will become a square plus x square whole power 3 by 2 due to a ring, okay, which contains charge and positive charge. Similar way you can think of negative charge also readily inward. So this is our electric field due to a ring of charge.